Tao. I'm an assistant professor at the Department of Visualization. I joined the Department of Visualization this September. Before that, I was a research scientist at TEAS, Texas Engineering Experiment Station. And also I was, I hope I still affiliated with HPRC and TAMIS, Institute of Data Science. So that's the current status of that's me. And I'll be continue working with the folks on HPRC, but this might be my last short course. In a consecutive, I'm not sure, 4 or 5 years here at HPRC to give a short course. Hopefully next year we'll have someone to pick up all the short courses and continue offering all the wonderful resources for our users. So I've been teaching Julia for a couple of years, and it was started as a learning process for me. Let me see if something wrong with slides. So someone from the mechanical engineering department, a professor, I forgot his exact name, he asked me to see if HPRC could offer some courses on Julia, because they are teaching some courses from mechanical engineering department about using Julia for some optimization, control, and other things. And they don't have the resources to offer this separately, so they asked us about it. Since I was working at HPRC and also working at college engineering, so I volunteered to teach this short course. So the goal of this short course is not trying to introduce, all the advanced features. It's just get you started with this language. And it also, if you don't have any programming background, this actually is a very good introductory to programming in general. Probably you might have heard that MIT is using Julia as a teaching language for some of their introductory courses for programming. And also there is reason why it's a good choice for this kind of courses. And you'll see, what I mean about that. So we have multiple parts, and the part one, I'll talk about what Julia is and why we want to use Julia. So first, Julia, it started as a teaching language for one of the professors at MIT to teach some of the programming and parallel programming courses, I think, mostly computer science courses. And gradually, it got, people got interested, and they started working on the compiler and all the runtime stuff, libraries, to make Julia run faster. And since Julia was created a bit later, and they can learn a lot from other successful languages like this, high performance Fortran, C++, Object-C, and all other languages created way before Julia. And they started this, start releasing this, the first version of Julia in 2012. And it suddenly got picked up by high performance computing community, mainly because Julia has a pretty good property of doing parallel programming and parallel computing. And you probably, if you go to high performance computing conferences, you'll see a lot of talks and and presentations about Julia. And Julia as a community, they are building this Julia community, and they are also offering Julia conference. I'm not sure it's annual or probably probably annual conference, or even half a year semi-annual conference. Something similar to Python conference. There's a big conference to get community together to discuss the future plans and discuss issues, etc. And the official website is julianland.org. It has been running for a while, since the first release, and you can find a lot of examples and documentations about Julia on it. So that's the official website. That's where you should go if you have any questions about any specific technical stuff. Go there and try to find it. That's how you learn Julia and possibly other languages in the same way. So Julia has been customized for, I put three adjectives to describe programmers here. Julia is targeting greedy, unreasonable, demanding programmers. Mainly if you really want to make full use of your computing resources, Julia is designed for you. If you have, for example, I have probably 8 cores in my 4 cores in my laptop. If you really want to make full use of it, I need to do either multi-threading programming, or I need to do the method passing programming. But Julia can make it much easier. it can make use of all the cores available for you, and you don't need to worry about the details, how to do the multiple threading and other things. Julia can do that automatically. So unreasonable here means if you really want to reach a certain scale, certain performance, Julia can give you the toolkit, and all the libraries and runtime can provide all the things for you. And also, if you want something to be done quickly, faster enough for you to submit your project and finish your your tasks, Julia is also a good choice. And Julia Computing is a company started in 2015, so it's like open source plus some commercial kind of license. If the whole package developed is open source, but they're providing services with extra fee, and they have been working closely with aerospace and Department of Defense and many other government agencies to support their development. And there's also a lot of academic users for Julia. So again, this is like, more or less like a roadmap for Julia, starting from a simple course related language for teaching purpose. Finally, now it's used by a lot of researchers and application developers for high performance computing development. So this one shows some kernel benchmarks. You can find it on Julia language website. And these are so-called micro-kernel benchmarks. These are not, head-to-toe benchmark. If you give me one application, there could be multiple kernels. You have an initialization section. You have a finalization section. If you measure the wall to the wall time from the very beginning to the very end, that's a different story. But here they're just measuring kernels. The kernels are doing particular stuff. And one reason they want to do this because for Julia, whenever you run a Julia code for the first time, the runtime will compile your code to a machine to be executable on the machine in a binary form. It's not like a Python. You have an interpreter, you get it, you input one line or statement, it'll run it. But Julia need to do the compilation automatically. It's so-called just-in-time compilation. And if you can include the compilation time and other overhead included, the total time will be much longer. You will need more time than what is shown here. But here it's just showing the micro benchmark. This just shows how fast Julia can be if you have very, very computer intensive applications. And Julia can help you to speed up your computation. In most of numerical code that you are doing simulations, solve equations, and doing those kind of stuff, the numerical kernel usually takes 70, 80, even 90, 95% of your time. So it's reasonable, to benchmark all these kernels. But again, if you consider this is overtime, if your application takes, probably say 1 second to finish, Julia won't be able to help you much. It can only make your code slower. So again, when you're trying to pick a language for your application, you should understand your application first before you go for the particular application to a particular program language to get started. So here it's a pretty popular website. It's called Readymonk. If you visit Reddit a lot and you visit all the IT forums and hacker forums, this slide shows up. This picture shows up pretty often. This shows the x-axis here is a popularity rank on GitHub, measured by stars and related projects. The y-axis here measures the questions and all other comments posted on Overflow. Mostly is when you have a question, you have an Overflow question, you have people volunteering their time to answer your question. So here is a measured number of questions or tags relevant to a particular language. So as you can see, if you have a lot of projects on GitHub, you're expecting there will be more people, interested in asking questions about it, and then you have more tags on Stack Overflow, and it has some linear correlation here. So I'm highlighted several of those languages that we have been teaching here at HPRC, like CUDA, Fortran, Julia, and R, Python. So if you look in here, the CUDA seems like outlier. As you can see, because CUDA is not a completely open source, the runtime and also the compiler, they are proprietary. NVIDIA has the control of it. So that's why the projects on open source project on GitHub is not that many. It's not that there's not big number of CUDA applications on GitHub, CUDA projects on GitHub. But now you have a lot of questions because a lot of people are using CUDA anyway. So that's why it's showing up like that. If you look at Julia is kind of different. It's just like it's open source from the beginning, and they're having a lot of projects starting on that. But not because the ecosystem is not that big. Not so many people are using it. That's why you are seeing Julia somewhere over there. So you can. No, I'm just trying to understand this position of this Julia and CUDA from my understanding perspective, and you might think it differently depending on your background and your understanding about whole thing. But this is how the or not just this language, but also other languages. You can look at them. You can probably figure out an explanation for why they're sitting at that particular spot. So the major feature of Julia is that it's very fast. As I just mentioned, if you have a numerical kernel, then it could be ported into Julia. It's something similar to CUDA. If you have a kernel, then it could be ported to CUDA, and it could be parallelized directly on using CUDA, and you can port it to GPUs. You are expecting more or less like 10, 20, sometimes 100 times speed up for certain applications. The same goes for Julia. For certain Julia applications, if it's if the compiler, the built-in compiler can compile code, optimize it, and you are expecting a lot of speed up just by converting to Julia, not doing extra optimization. That's a default feature for Julia. That's the free benefit for using Julia. So also it's a general support, general language, general programming language, like Python, like C and Java. Those are general purpose programming language. You can use a Julia to build a website. You do data science project. You can do almost everything you want with Julia. And also, like Python, you don't need to declare a particular data type for your variables. In C, and those are C++, those are strong typed languages, and you have to declare your variable before you can use it. But Julia is dynamic. It's automatically detecting the type of your language, of your variables. And also, I think lastly, I think we can skip this too. Composable is one of the features of Julia, that it's something working like Python packages. You can use a Julia package in a similar way, almost like that. And also, if you are not familiar with Julia and other programming, if you know Python at least, and then you can compare Julia to Python. It's very comparable in many ways. So it's more or less like Python on steroids. It gives a bit of powerful boost to the Python programming language. There are multiple IDEs, which is standard IDE means integrated development environment. For those of you who have been programming, a good IDE will save you really a lot of time for setting things up and deploy it and doing debugging, all those things. So if you're a beginner, programmer, learn to use a one IDE, actually, probably Visual Studio, or here I'm showing you the Juno for Julian. Python, you have PyCharm and IntelliJ for Java. There are different communities and different groups of people that have their favorite IDEs. My favorite IDE for Python is a PyCharm, which is fabulous. And I haven't really done a serious project with a Julia myself, so I don't know, if this Juno it seems to be pretty nice, but I mostly use the command line interface for Julia myself, just for testing. Sometimes I use the notebook, which I'll be showing in the next slide. So Julia Notebook here is not only supporting Python. For those of you who have been developing Python, it's Julia Notebook. It's there, and you can run it on Google Calamitary. You can create your own server, Jupyter Hub to run it. You can create Jupyter Notebook, which is a different. You can run that. You can also run your Jupyter Notebooks on MyBinders. Those are free open source. I think it's a free service provided through some sponsorship from some companies. But you can also run R and Julian using Jupyter Notebook interface. So they are supporting Julian, Python, and R. So that's Jupyter, as a Julian. JU is Jupyter, Python is PYT, and I'm not sure about this E is, but R stands for R, the language used a lot by statisticians and people doing data analysis. So another very popular interface is a command line interface. And this is called a REPL. For those of you who are familiar with Python, Python has a similar interface. You have IPython, you have Python, default Python. If you run Python, you'll see something like this. So what REPL stands for read, evaluate, print, loop. So read, whenever you type something, this interface will reading whichever you type, and then it will evaluate whichever you type in as a statement, and then print whichever whichever the output is from your statement, and it will continue looping process. So it's like a dead loop until you quit. No, dead loop, it's endless loop, infinite loop, I'm sorry. It's like an infinite loop until you quit. So same goes for Python, IPython interface, and also, it's very similar to IPython interface. And if you're familiar with the shell script, you have a shell in a similar way. You have MATLAB, Mathematica, Maple. There are many Octave, many of programming languages. They have similar interfaces. So it's a pretty common thing. It's nothing fancy and nothing special about Julia doing this. So next, this part will be more or less like a hands-on session, and we want to get you all started, get your hands dirty on our machine. And I'm showing here is a Grace, which is currently running, and it's now currently the main powerhouse for HPLC, and we are a lot of users are now using Grace for their research projects. It's pretty big, and this just show you the login nodes. This one doesn't show you the computing nodes, which is a gigantic cluster. It's about $10 million. So that's give you the price tag for that. For the login nodes, we have 4 type login nodes. We have 2 login nodes without GPUs. If you're not using any GPUs, just do very simple programming, testing. You can log in, Grace 4 or 5. Usually when you log in, the system will automatically finds a node without, with a relatively less load, and put you there. So we have a load balancer to decide where they want to put you there. So when you log in, just log in grace.hplc@talmud.edu, and you will be assigned to one of those. Now the problem is if you really want to do GPU-related programming, and unfortunately, if the system decided to Grace 4 or Grace 5, you need to SSH to Grace 1, so that you know that you are on the right node to do the right thing. But usually, it's I think it's by default, a lot of default login will be Grace 1, I assume. But if you want to do any other, if you want to do some inferences and other things, T4 and RTX 6000, those are pretty good nodes. And each node has 384 gigabytes of memory. That's memory. That's not a hard drive. That's memory. 384 gigabytes, and each node has 48 cores. So if you do multiple threading stuff, it's pretty powerful. It has HDR 100 InfiniBand, 100 or InfiniBand. I think it's 100 gigabps or even more. I forgot exactly. Probably more than that. So the network connection is pretty high. The bandwidth is pretty high and latency pretty low. If you want to transfer between nodes, you don't need it to. But if it's necessary, any data transfer between all those nodes will be done automatically. But usually, because the file system is shared among the login nodes and the computing nodes, so you don't need to copy files back and forth between different nodes. When you log in, you'll see the same environment. And we don't have a lot of space allocated for each node. We just we have 2 480 gigabytes SSD and 1.6 terabytes of ME, which could be allocated as a virtual memory used for your node. So that's the login node for Grace. The easiest way to get to the system to use our portal. This portal is a web-based interface. If you click HPLC portal, it will bring you to the portal interface. If you are off campus, you have to log in VPN, and without a VPN, you cannot get access to this website. It's only within our NM firewall. So it's protected by the CIS system. I assume everyone can get here. Feel free to ask me a question through the chat channel, and I'll try to answer your question. So let me go back to the slide. So after you get in the portal, get on the portal, if you go to the, this is a website, PNC website, that's one way to get there, and you can click the button here, this pointing you directly to the portal. Anyway, you can also visit hpnc.tamu.edu, and the very right menu here, the very right menu, you click it, you'll see two menu items. The second one here is a Grace portal. If you click it, it'll point you to the same website. And then now this is the part. There are a lot of menu. You can explore others after this short course. But today we'll be using just one menu item. If you go to clusters, and there is a one said Grace shell access. So this will give you a web-based shell access to our system. It's just like a login with a mobile external. If you use it before, if you're on Mac, you have a Mac terminal. If you're on Linux, you just directly open up your terminal and do SSH grace.tamu.edu. And here, this is a web-based interface, which is portable. Anyone with any system, even if you are running OS2, I'm sure you guys know it's another different system. As long as you have a web browser, you can get access to our system through this web-based interface. This is pretty nice, very convenient. That's a recommended way to get access to our system. For most of our users, if you are advanced users, you prefer the terminals, you can use terminals, but this is a very clean way to, easy way. You don't need to install anything. After you click the link, you'll see this page. It's just like a terminal when you're logging. It's exactly the same thing you'll be seeing here. And you need to authenticate the door, and you need to push the button and get there. So let me try to log in myself, and then I'll go through this with you all. And here I get a cluster, Grace, and I need to type in my password. Okay, I need to authorize it. Okay, if it's your first time, there's some important information about our policies and also other interesting, website, and you can go there and check out the systems and also some other things. There's also a YouTube channel, and there are a lot of video clips and get you started on our system. And also make sure you're doing everything legal here. You're not supposed to be doing any Bitcoin mining and anything like that. You're not supposed to be doing anything just for your own profit. This is paid by tax dollar, so make sure you follow all the rules. And also at the bottom here, you'll see the quotas for you, because this is a shared system used by thousands of users. And you'll see the limit about for the directories. You'll be given, I'm a staff user, a different user. I have probably two different directories that you don't see, but for most of the users, you'll see these two directories at least. One is under your home directory, and another one is a scratch space. The home directory is where you put your files and you want to keep for a while, but not that big. If you have a very big files, you're highly recommended to copy your file to scratch space. And I'll show you how to do that in a second. But scratch space has a much higher file limit. We have a 1 terabyte of storage for you, that you can save up to 1 terabyte of files. Probably it's just me or probably everyone. What do you think? What's your quota? Oh, it's also 1 terabyte. That's good. So probably now we have more storage. Previously on Tera and Ada, we have different limits here. And also the file usage you have, because some people are They might not be saving a lot of a very big file. They might be saving like millions of small files. That's also troublesome for our file system, because our file system is supposed to be dealing with very large files. They're not very good at, especially the system we're using is not very good at dealing with smaller small files. So that's why it's such a hard limit here for number of files you can use. In my case, it's about 250,000, probably the same, right, for everyone. So that's a limit. If you don't know, maybe there is a command called show quota. So that's a command you can use to run to see your usage, quota usage. And sometimes when you are creating some Python virtual environment or Julian packaged repo might not be created in the right place, you'll see your quota will be used quickly. And then whenever you see something like quota is out, you're out of your quota, etc., you just run this show quota to see if you really run out of quota. You probably need to delete your files. If your data sets are so important to be removed, you can email HPLC help desk. There are some temporary policies for you to just keep your file a bit longer, but you needed to make sure you'll clean up your data afterwards. So that's the command line. If you get here, you're almost there. Running Julia is very compared to Python and all the other packages, it's very easy. So let's get back to the slides, and I'll show you how to do it. So step one, let's go into step one first, because you don't know what packages you want to load for Julian. Usually, when you're getting on the new system, you don't know that. What you do is there's a command line called module spider. I have no idea why it's spider. Probably a module search might be better, but that's the way how all this open source software work. Can I clone my? Yes, you can. You can use a git clone, and you can try that. Yes. So do module spider Julian. You can find we have only 2 Julian modules installed. So what's a module? Module is like a Python package in a sense. It's like a Python package. When you load a module, all your, for example, if you load a module Julian with a certain version number, so all the Julian command line will be pointing to the loaded version, because we might have multiple users use different versions of the same package. That's why we keep not just a package, but also different versions of packages, and also all the dependencies of this package. It's not the easiest thing. Think about it's like a tree, structure. You have all the dependencies back to different roots, and there are a lot of upstream packages you need to make sure they're all compatible. So it's not an easy task. So we use this module management system to do this. So module spider will help you to find the particular module you need. And the next thing you do, you can do module load. Module load will load the particular pattern. What you do, just copy paste this line, Julius at /1.6.1. That's our latest version installed on our machines. But the latest version of Julia, as I just mentioned, is 1.6.3. You can download that directly from the Julia website. I'll show you how to do that in a second. Step 2 will load the module. After you get this module loaded, this Julia 1.6.3 will be available for you, and all the libraries will point to the right place. All the included files will be pointed to the right place, and everything will be ready for you. And then you just need to start Julian. That's all. It's not complicated, right? So, after you get familiar with this, you can forget about step 1. You don't need to do the spider. You just do the module load. And also, if you don't type this, /1.6.1, the system will automatically load the latest version of Julian for you. It works for Julian because we don't have so many modules for Julian. If you are doing, say, Python development and you don't know for sure which version you want to use, module load Python might work. But in most cases, it's not a recommended practice. It's recommended that you load the module plus the version number, so then you know for sure which version you're loading. Okay, so what I'm putting in step 2 here, that's a recommended practice for loading, for loading Julia packages. And then you can run Julia. So that's how you load the pre-installed Julia module. And then this page shows you, this slide shows you where you get to and to download this, zip file, and then you can unzip it, and then you cd there and run Julia. But this time, every time, if you don't change your system environment, every time you go there, you need to cd the right directory and run Julia. So what module loader does, it will help you to get rid of this first line here, plus some other environment settings. So whenever you type Julia, Julia will be automatically pointing to where the loaded module is. But here, when you do this yourself, if you go to the, if you go to the Julia website and find the version works for you, if you are on Windows, you can directly download Julia and run it on your Windows system for your development purpose. But on our system, you cannot do that directly, because when you click the link, it will download to your laptop. One way to do it, you can download to your laptop, and then you can use a file. I'll show you in a second to upload it to your directory. You can do that, but the probably most convenient way to do it is just find the version here, which is a generic Linux on x86. That's our architecture. You click the, you right click it, and then copy the link address. Okay, that will give you the link to the repo or to the directory. Where's my dash here? So I first go to the scratch space. So whenever I type in this dollar symbol, that means I'm going to refer to a system environment variable. So this env shows all the system environment variables I can use, but just be careful, don't modify those. In some cases, you'll mess up your shell. You have to log out and log in again to get everything reset. So env will be showing you all the system variables that loaded to your current system. You don't need them. These are just something set for you automatically by our system. Whenever you do a module load, part of this environment system, all the system environment variables will be updated when you do the module load. And scratch is one of them. If you go to, say, $scratch, which actually is the same thing as a scratch user Jian Tao. If you go to this one, you'll get the same thing. You'll just change your directory to the same directory. But here it's not Jian Tao, it's will be your net ID. That's your scratch space where you store your files. So after you get here, what you do is do wget, and then because you just copied the link, right? You can just paste it. I'm not sure if, wait a second. Did I copy that? Okay, I right click it and then copy link address, and then Control V here. I works on my system, but it might be different for a different system. Control V will paste the link to the environment. wget will download the file to your current directory, which is the scratch space. You can also do it on your home, but it's not recommended because scratch is usually faster and it's larger, and the home is mounted across all the nodes, and you want to be careful about what you want to share, what you want to use your home space. So after you get this zip file, it's a gzip file downloaded. The next thing, if you go to the slides, it just asks you to unzip it. You can copy paste it, and you can type in that. So the trick to typing here, you can just tar zxvf and then Julia, then use the tab key. Use tab, it automatically showing you give you the hint about what you want to type in. So you don't need to type in everything. So what this does, this will be unzip this Julia packet under your home directory. I'm sorry, under your scratch space, which is this directory. So everything's here. Then you can cd this bin, if you cd this Julia directory, and then cd bin, you'll see the Julia command line, and you can run it. Now I'm running the one I just downloaded and just unzip. So it's a portable green Wales install. You don't need to do it like a Windows install. You don't need to change your registry and all other stuff. It's just unzip it, you can run it. When you want to quit, you just Control D. It will get back to your shell. Go back to. So I'll stop here for a couple minutes. You can take a short break, and we'll get back to this in a second. I hope you all can get here. Just get your REPL interface up and running.
If I do CD bin, will it open up the IDE?
No, if you CD bin, it will just CD to the bin directory. But then you need to run Julia to open that. /Julia will run the Julia command line.
Inside the bin directory?
Inside the bin directory, because Julia, that's executable.
Right.
And this command line just give you everything in one single line. Actually, it's two commands. It's just CD this directory first, and then run Julia. It's like two. But here I put a semicolon here, put that in one single line because I don't have enough space here for the slides. Can you all see the REPL interface? You can. How about you? Can you see?
It doesn't have the bin.
Let me check. Sorry, let me. No, you go back. Oh, this is LS, top LS.
You said what?
LS, just LS.
Okay. Yeah. Yes.
Yeah, this.
I just said this.
So which word did you down? Put it down different word. No, not source. These are precompiled ones.
Yeah.
This one.
Should I?
This one.
And so I right click it.
Right click, copy it, just do whatever you do. You don't download the source. Source means you have to compile everything to get to Julia. We are building the Julia from scratch, but here we're just downloading the precompiled version of that. I'm not sure if anyone on Zoom has trouble to get the REPL started. Okay, seems everyone's fine. So at least if you can get a REPL started on our system, you can start doing Julia development on Grace. And also depending on the nodes, if you are lucky to be on one of the nodes with a GPU, you can do GPU development with Julia. Otherwise, you need to switch to a different node. As I mentioned, if you one of the unlucky ones to be logged into, the system will decide where you be logged into. If you be logged into Grace 4, Grace 5, let me see, where's my, sorry. Assuming you are on Grace 5, okay. Something's wrong. Okay. So on Grace 5, you don't have NVIDIA packages loaded. It's just a pure CPU package. So we only have this embedded GPU card, which is definitely not the GPU card we are talking about. So this is just for video output. You cannot do any computation with this GPU. And the way to do it, you need to do a SSH, or you can quit and log in again if you are lucky enough to get back to Grace 1, or you can directly link to Grace 1. But on the port interface, you don't have a choice to go to which Grace login node. But you can go to Grace 1. That's what I usually do. If I got to log into Grace 4, Grace 5, then just do the same thing. And you can get on Grace 1 or 2, or 3 or 4, whichever node you can log in. Just use a SSH Grace and the node number 1, 2, 3, 4, 5. Okay. Now you remember I log in grade 1 through grade 5 because I was a grade. I can, if I want to go back, just exit. Now I'm going back to grade 5, and then I exit one more time. I'm going back to grade 1 because I was logging to grade 1 in the first place. This like something that you all started on systems, and Julia itself as a programming language is not much to talk about. But I'll go through the slides anyway. So for those of you who are new to programming, this will be really, really helpful for you to get started. After you get the repo out, if we can run the repo, you can start to install the packages. Think about now you already have Python installed. You don't have any Python modules right there. What do? You need to do a pip install to install the Python packages. The same goes here. You need to add packages. But before you do that, make sure you set the Julia Home Depot. That's the Julia Depot. Set this system environment to be a directory under Scratch. Otherwise, you'll use up your home directory quota quickly. Sometimes, I don't know why, it takes a lot of space and a lot of files to get this installed. Similar to Anaconda. If you are familiar with Anaconda, sometimes it's just grows like crazy. You're usually use up your quota and your size, both the size and number quota with a couple of working environment. So what you do, you can just copy and paste. Don't forget, don't copy the first $sign. That's just showing you that's a command line shell prompt. Just copy, export Julia this, and then you can go to your own. This one is already terminated. Control V. So if you export Julia deport, let me see if I can. Enlarge my window size here. So this will this will tell Julian that where you want to install your packages. And then you start your Julian, and everything else will be just normal. Just start Julian. I'm sorry, I didn't load the Julian yet. Let's start Julian. And then there is a one called right square bracket. It will get you into the packet shell. If you want to go back, just use a backspace. It's very interesting. I never expected web interface can do this. With one stroke, you can go to the packet shell. With a backspace, you'll go back to the original Julia shell. So on this packet shell, you are already now into default environment, which is a version 1.6. It's not showing up on my screen here, but if you look at your own screen, you should be able to see version 1.6. That's a default environment created for you. You can create your own environment, which is not something we want to talk about today. You can activate, whatever environment you can start on that. But let's just use a default shell. It's fine because, we'll be synchronized with our shells anyway. And then we can add packages. We can add, say, plots. I believe that's the one So when you do this, the very first line you can see the registry is at my Scratch space. That's what we want. Yes.
How do we enter the package shell?
There's a right bracket and a right square bracket. Is that the right way? Here.
Oh, I'm having trouble doing the export part. It's saying it's not finding such a file.
Do you copy and paste this line?
Yes, but where should we copy? Where should we paste that with that?
You copy and paste it to your shell and just run it.
Yeah, I'm getting an error saying
just like first line here, you just run it here. Let me check. No, don't copy the dollar symbol. Don't copy the dollar symbol there. Is just for you to. I just want to show you all. That's the command line saying, don't copy the dollar symbol.
And how do we exit the Julia record?
You backspace. You can go back to the Julia prompt.
From the package, I could go to Julia using backspace, but from Julia, if I want to go back, you can just do exit and exit. Yeah. Yes.
Does it work for you?
Yes.
Okay.
Backspace was not.
Okay, I'm just backspace going back to the Julia shell.
From shell.
Yeah. Does it work?
Yes.
Okay. So when you're copying that export, don't copy the dollar sign, dollar symbol.
Is this doc available to us from where you're copying the app? The Google Doc, is it available to us?
The slides, right? Or
where is that slide available? Sorry.
I shared it on. That's a good. You can get on. Let me see. I should have shared it. You can type in. I think this is very simple. Tag HPRC Julia. That's what I created this short link. TXAG. Yeah. HPRC Julia. Why it's so slow here? I don't know why. But let's go back to the slides. So, select the machine work for us. Do you all have access to that? Are you already installing? Are you already installing like plots? Okay. To get into the package, just type this thing.
Inside Julia.
Yeah, inside of Julia. Like this. If you type this, you'll see the, okay. Then you can just add plots. It's like a pip install, a package module. I know this is kind of tedious for first-time users, but after you get used to it, it's just normal thing. Okay. Now, since you're still installing, I assume. The best way to learn how to do it, when I show you the slides here, I want you all to type it on your repo. The easiest way, we don't need to wait for that one to fill it. We can start a new one. We can create a new shell, go to the, repeat what you just did. Go to the cluster and you can grab shell access and just do this one more time. You can create one more shell. So it's almost unlimited, about how many shells you want to open here. There is a limit, but usually I don't think you will be getting to that limit. So this is how I get here. Just repeat what you just did and get to the repo. That's all we need, because the other one is installing. Let's just keep it installing because we still need that. Oh, this one's almost done, seems. When I go to this one, it will automatically open a new tab for me. I go to the portal and then create a new Grace shell access link, and then I get a new terminal. So this one's almost done. And anyway, so let it run, it doesn't matter. So assuming you are all here, I'll get to the repo. So I'll show you the slide, and then I'll ask you to type in stuff, and you can just try things out yourself. So think about when you try to figure out a version of Python, what will you do? Just, Python, the underscore version underscore for most packages will be working. For Julian, you can just direct type in the version info, and then or just the system environment version itself will be like a keyword storing the version information. And it will show you the version. I want to increase my font size, but for some reason it's not working for me today. Oh, here we go. Now it's better. So there's also some shortcuts here. Control L will clean up your Julia shell. That's a repo, Julia repo shortcuts, Control L. So now I want to do what it's called a version info. It'll print out the version of my installation. And also my operating system, the LLVM, which is the compiler used to compile the code into machinery to compile into executables on a particular system for the optimization as well. And also it's print out the CPU, which CPU are using running at what frequency. It's some basic system information. Okay. Now there's another thing I want you to look at is like this one. Square. Let's take a square root of 2. So let's just get a quick start here. That's kind of fun thing to do. I use a backslash sqrt and then tab. Oh, I'm sorry, this one's not showing up properly here. Probably when I increase this, it will change the way how it works. Right, I believe. I just want to show you the square root symbol. Backslash, I'm sorry, backslash.
I think this shell doesn't have.
Okay. But it still works, it's just you couldn't see it.
If you type the question mark and hit enter, just hit enter. It doesn't show all the operations. If you do it on a different cell,
yeah, it works.
or if you do it on ES code,
yes. Yeah, but anyway, so these are some things you can try out on, if you have a different shell, not the web-based shell. This might not be a good idea for you to, try all these things. But anyway, what I'm trying to show you here, because Julian is supporting all these spectral symbols, which you can print out not just in the ASCII. What's this one is called? All this symbol, which is. It's a new, wait a second, where's so these symbols will print out more or less like small image icons files, but it's in the new symbol table. Traditional ASCII is just, the ASCII we know 256, but now with supporting this, this is new encoding, and you can have all these mathematical symbols, typing all the Greek symbols, pi, and etc.
how do you get that for IEN?
There's a backslash in.
It's here, showing us oh, I see. But that's not going to work on the web shell.
It's not working on the web shell.
On the
On Windows, if you have Julia installed on Windows or Linux natively, that will work.
My desktop is open Windows terminal. Yeah. And then if you have Julia, however you would. Yeah, it's open Julia. Yeah. You should be able to see all.
And also, these are some keywords, key bindings. If you want to quit, Control D will exit. If it's empty, and Control C will interrupt and quit. I just mentioned the Control L will clear the console screen. I also tried it myself. It seems to be working. And if you want to go to the package repo, it will use this. These are the reference you can try out. So that's now goes to part 3. It just works just like a calculator here. I tried this on, I use the same slides for Python, MATLAB, and Fortran, actually. It's the same thing. We first use all this language, or the programming language as a calculator. All this standard way of doing mathematical calculation, arithmetic operations are all working like you expect. If something is wrong, you can easily figure out, because all these operations have been well tested. I don't think there will be any problem with all this. Just use it as what you understand mathematically. That's should be working as expected. It's just like for different languages, also the symbols are different. Sometimes you use the double stars for power. Now you have up crank it, bra. So how to call it caret. to the power of, and then you have modular, and inverse division. Division is different. So the order of this operator is following standard way. The power usually has the highest the order of operation, and then you multiplication, division, and then you have plus and minus. But it's always a good practice to put parentheses around some operations. So that's recommended. Whenever you have pretty lengthy mathematical expression, it's good to put parentheses to the parts that you want to go first. And even if it's following certain the order, but just in case it's easy to confuse the people, or if it's very long for you to understand what's going on, it's helpful to put parentheses just in case. So I assume you all have access to the repo. Just try this couple of lines. Just try it quickly to see if you can just use Julian as a calculator first. I'll give you probably 1 or 2 minutes. Just try it out.
One small issue that I'm having, and it's very minor. Whenever I'm trying to use the special characters, I'm getting a box with a question mark.
That means it's not showing up there, but
What are you Windows 7 or Windows 9?
No.
which browser are you using? I think it depends on the browser. Which browser?
No, I'm not doing it on the browser. I'm doing it on the Julia.
Yeah, the generator browser is just command. Open Windows 7. So the Windows, just type. Or fiesta. And then if you have it added to that, just type to it.
All right, to add the path. Okay, I'll find the path.
You know how to add that?
No. CD.
Do you have any questions from our Zoom attendees? So this is probably the, I think it's a kindergarten level of Julian. How to put a Unicode symbol for belong to is, oh, okay. That's I put it in the slide, it's a back in, I believe that's it. And then tab. So the Python, I believe new version of Python also supporting Unicode, but I don't see people use that a lot. But Julian is supporting this at the very beginning, and a lot of people really like this feature. And some of them even use a Unicode symbol like Greek symbols for their variables. And it looks very much like a math book. When you look at a Julian code, it's like reading a math book. So you can also have, relational operators are also similar, or if it's not an exact same, but it's very similar to many other languages. And again, not equal to, there are special symbol you can support if you have a native Julian installation on your system. You should be able to see this not equal to symbol, which is much nicer than two symbols, explanation symbol plus equal symbol. The same goes for less than and greater than. And these are just ways when you compare two expressions and to see which one is bigger and smaller or equal, not equal to, then you put this into your conditional statement. And for branching your business logic. And these are relational operators. You can try a couple of examples. The beauty about this repo is that you can just copy and try it. If it's not working, you just try again until it works. But so Boolean and the bitwise operators, these are for logical and operations. When you have a true or false value, you can easily see if you have true and true, you get true, true and false, it will be false. and or is different. So it's just like a standard logical reasoning. If you are not familiar with this, it's fine. Don't worry too much about this. These are very, very basic computer science concepts. When you have statements, you need to, you have some statement you want to check if it's a Boolean value, if it's a true or false. You can have operations like this, push them together with all the comparison, relational operators. Those are usually used combined together. So if A is greater than B and C is greater than D, then you can combine them together and give you the conditional statement. Based on the conditional statement, then you can do something, right? That's a Boolean and bitwise operators. You can also do the shift. If you do the shift of 1, it will give you, like a power of 2 when you shift 1 bit. And you can easily do the power of 2 to multiple, number of multiple orders, and by just shifting the bit to the left and to right. Also, non and infinite, these are two special types, in not only Julia, but also many other languages. In Fortran, C, and Python, we all have this non, and I don't think I'm not sure if we have an infinite in, I don't think we have an infinite in C, and then I believe in Python, do we have an infinite in Python?
Yes.
You have an infinite, okay. I know non is everywhere because every language will need this non to detect if you have any non-value, not a number of values in any languages. In Python, I'm sorry, in Fortran and C, if you are doing any scientific computing, whenever non appears, whenever an operation use a non as an input, you'll get non as the output. So if you have a non appears in your calculation, you'll have tons of non generated in your code. So that's why easy for you to catch errors in some sense, even though you probably don't want to see that, but in some sense, in some cases, it's helpful for you to debug your code. In Julian, nons and infinites, there are different things. Also, it's different for different languages. The definition is kind of like very strict here. Infinite itself, it's not a non, it's infinite. So that's something different. When you have a number which goes infinite, it doesn't mean it's not a number. It's still a number, but it goes to infinite. And you have a positive infinite and a negative infinite. Non itself is like you have a 1 divided 0, you'll get a non. I'm sorry, it's probably not. Wait a second. Usually in Fortran you'll get 9, but in Julia it's not. If you check if 1 divided 0 is a 9, it says false. So it will give you a probably positive infinity. But again, whenever you have all these exceptions in your mathematical operations, either non will be popping up or infinite, depending on your operations. If you are doing some calculation, between strings and different data types, and with the numbers, you'll get some, weird results. That's probably that's when the line appears. But anyway, so just be careful. Non and infinite, these are different. So just in case you are not familiar with that. So variables here, like any program languages, you need variables. Variables are really, really powerful. Just like in an equation, when you have x and y, you write down the equation, you can solve this equation. X and y could be anything. As long as you are satisfying your equation, you can use x, y to do all the things you want. The same goes for variables here could hold anything, depending on different types. You have a floating type, which is a real number, and then you have integers, and you have char, which is a single character. You have string, which is an array of characters. Then you have a Boolean variables, which is just 2 and 4. Only 2 values for Boolean variables. And here I'm showing you some examples. You can try that. And you can also, there is one function called a variable information. If you type in and run it, you'll see some output about the variables defined currently in the memory. So technically, each variable is just a symbol pointing to a particular memory address. So whenever you want to get some to figure out what's inside this particular variable, you need to you need to refer to the variable by the name, and then the system will try to find the address for the variable, and then extract the data out from that address. So that's the idea of a pointer in C, and in Fortran, something similar going on there. But it's just the way how the things got organized is just different. But the best idea is just to have a variable which is the name to the memories to a memory space. And the memory space is a holding place, like a container for your variable, for your values. And then you can get everything up from that. So you have complex variables you can define like this, and then you can use Unicode, to define your variable, which is pretty fun to work with Julian. You can define anything you want. But again, Unicode itself is limited. It's not unlimited. There are some predefined symbols, and there are some other symbols probably you can define yourself. And naming rules for variables. This is almost the same for all the imperative languages, and also at least in all the programming languages I'm familiar, like Java, C, Fortran, MATLAB, all this. They require you to put a letter as a first. Use a letter as the first symbol in your name for the variables. Like here, 4c equals 12. This will give you error because you cannot use a number as a first character of your variable. But underscore works, and also Unicode characters work. So, and also Julia is a case sensitive. Do you guys remember which language is not case sensitive? It's case insensitive. Do you know the language that is? No, C++ it is. Which one? Anyone? No. The only one, the one I know is Fortran is case insensitive. And someone just replied, yes, Fortran is case insensitive. There's another one I remember. I'm not sure Pascal or not. Pascal. I believe it's either, you can check, later on you can check. Pascal, it's PowerShell. Oh yes, I mean DOS, PowerShell is, on Windows, if you're using DOS command line interface or PowerShell, that's case insensitive. Back then it's called DOS, it's a disk operating system. It's case insensitive. Or non-casing, okay. That's my fault. So yeah, SQL, it's non-case sensitive. You can use capital case, lower case in your querying language. It's great. See, we have some decent programs here in our workshop, in our short course. So let's see, that's some basics. What I'm talking about here is not just limited to Julia, except some, some very strange stuff like say, Unicode is used for variables. It's not widely used for other programming languages. But many other things we're talking about here, it's just generic programming stuff. So when you can display a variable, you can use a print, you can directly type in the variable, it will print out the value, or you can just print a new line, that's I don't know, who designed this language, but I don't think it's really a need for you to, it's just save you a backslash, n, which is a new line symbol. But anyway, that's, whoever designed it, they have the freedom to do whatever they want. So this is a very simple exercise. What you are doing here, we'll get two variables, A equals to 4, B equals to 17.2, and we want to calculate some expressions. The first expression is just a simple mathematical expression, try to get the 1/3 power of B plus 5.4. And then you have the last two here will be the Boolean values. You should get a Boolean output. Is A greater than B and A greater than 1? If both statements are true, you'll get true value. Otherwise, it'll be false. And the last one is compare A and B. So these are some expressions you can use to calculate this. And these are building blocks for your programs. Whenever you write any programs, you need this kind of small building blocks to calculate certain values and use a value to decide if you want to go here or go there. That's your if statement branches, and then you have loops. All this put together, it's your program. So these are building blocks for for any programs. So some basic syntax for statements. Statements is like a sentence. You're talking for any language you're learning, no matter it's Chinese, English, French. You put all the words together, you form sentences, and then you put sentences together, you form paragraphs. You put paragraphs together, you form articles, etc. In some sense, kind of similar. When you write a program, starting with defining variables, expressions. You put expressions together, you get statements. You get put a statement together, you get programs or functions, and then you can build up things based on that. Always starting from smaller one to big blocks. Now, begin and end. This is all the standard block you can use, but usually probably people don't want to write extra things just to save some typing. It's easier to use a parenthesis if you want to put everything into one compound expression. But use a semicolon to separate them. If you want to put every statement in one line. So these are two ways to organize your statements, like x equal to 1, y equal to 2, and x plus y. These are 3 statements. In the first block I'm showing here, this just put everything into the beautiful block, begin and end block. And then you set the output to this to z. So everything inside calculated from begin to end will be the output will be saved into z variable, which is we know it's just a memory block. So it's z as a label to pointing to the particular memory space, which will be storing the output from this statement. The same goes for the second one. It's just z equals to parentheses, but everything will be in one single line. This is pretty flexible. So for those of you probably familiar with Fortran 77 and earlier, you need a very specific ways to write your code. You have to follow the formats exactly. Otherwise, your code the compiler will tell you some error messages. But nowadays, for most of programs, it's very flexible. It's mostly free format programming language for all the new ones, newer languages. So this is another way of doing it. It's just I have different combinations. This will just calculate that. It doesn't really save it to anywhere. I don't have a z equals to before that, but just do the same trick. You can. It's kind of free format. You can freely arrange in any way you want. So one thing I want you to try. Let's get rid of the semicolon for the first one. Will that work? Let's just type in begin x equal to 1 without semicolon, y equal to 2, and x plus y, end. I'm not sure that will work. Can you all try that? It works? Error message. So that means, the parser for the compiler, for the interpreter will have trouble to understand what you're talking about. There might be some ambiguity there. Because if you don't put a semicolon there, it could be, it could be x equals to 1 times y, and then you have second equal sign. I think that's how the interpreter got confused. So again, if you want to put everything in one line, use that. But for the second one, you can get rid of the semicolon, mainly because you have a new line there. The new line will tell the interpreter that you have a new statement. So it will evaluate these 3 separately. Okay, so that's all the basic statements, just like any programming languages. But Julian is a strong typed, it's a dynamically typed programming language, but internally it has a pretty complicated numerical data types structure, like this one I'm showing here. Now we just look at a number here. It could be a complex number, it could be a real number. So the real number could be abstract float, which could be inherited by big float 16, 32, 64, etc. And for integer, you have signed integer, big integers. Signed integer could be into 32, 64, 16, and 128. So the number here, like a 16, 32, 64, these are representing the number of bits used to represent this particular type. If it's float 16, that means it's using 2 bytes, which is 16 bits. So every 1 byte is, I'm sorry, 1 byte is 8 bits, right? You all know that's a standard in computer science, very basic, computer science 101. And then float 32 will be using 4 bytes. And then you have 64 will be, 4 times as 8 bytes. So the more bits you have, the more information you can hold. If you have only 8 bits, you can only have up to 208, 200, 2 to the 8th power, it's 256 possible combinations. But if you have a 32, it's much more. I think it's 60, whatever, 1,000. And then you have a 64, that's even longer. Basically, you have more precision, you have higher precision. So when you want to do any numerical calculations, you want to store, the more significant digits in your decimal points for your decimal, representations. You want to have more digits, and then you probably want more, more bits to save your number. So that's why we are doing scientific computation. The float 64 is a default setting. It's a so-called double precision. And float 32 is so-called single precision, and float 16 is so-called half precision. Okay, so the same goes for integer numbers. So the more digits you have, the more numbers you use, the large you can represent your number. Now you look at this. So there are 2 very special ones. One is called a big float. Another one is called a big int. So these 2 can play some tricks to hold arbitrarily high precision numerical values. Those are something special. And I think we will have some example. We'll talk about that. So now look at the integer data types. You can see that what's the, with the integer 8, you only have 8 bits. 1 bit is 0 and 1. You have only 8 bits to hold the data. There's not much you can, you don't have enough storage to store all the information. That's a physical limit. Even though it's mathematical, but in some sense it's called a physical limit. You don't have that big space to store all the information you need to store, unless you give me more bits. Now with the integer 16, you can save more information, and you can store all the way to -2 to the 15 to +2 to the 15, etc. So Boolean is kind of different. Boolean is just 4, 2. It's just 2 values. Actually, you can use I don't know why it's using 8 bits, but it's just easy to handle. Maybe just 1 byte. Actually, you can just use 1 bit to save Boolean, but it's just make it, I think less, probably more troublesome to handle 1 bit than 1 byte. So they use 8 bits to store the Boolean value. Okay, so to handle big integers, this is something I want you to try. This is kind of fun part for Julian. For given data type, like integer 64, if you use a type max, this will give you what's the maximum numerical value this integer 64 can support. Now, if you plus this by 1, you'll get some interesting output. You can try that. It's like a circle. So actually x plus 1 is equal to the minimum value this can support. It's kind of going back. But that's just because it's already going out the bound of this special type. Everything we are doing in the second and third line here is just the definition, how they define the maximum and how you treat if you go beyond the maximum. That's what the system is using. Whenever you go beyond this maximum value of the supported data type, it will go back to the minimum. It's going into the circle. Now, the last time is kind of interesting. If you are using big, this big function will convert this data type into big integer data type. If inside is an integer, it will convert that into big int data type. If it's a float, it will convert that into big float data type. Now you can do this maximum number is 100 power, power to 100, 100 power to 100, power of 100. And you can print out a long string over there on your screen. Do you want to try that? No, this, let me copy and paste this one. It's getting so lazy to type stuff. Now here we go. You can do 1,000. It's just so quick. It just takes some while to print out, but the machine can do this quickly. They have some internal algorithm can do this very, very fast. I'm doing this like 10,000 power, and that's how you abuse your system. But anyway, this just tell you, how powerful all the syntax are. Even though look, it's not that complicated, but with this one simple big function call, it's more or less like a typecast for other languages. But here it's just converting this into a big integer data type, and then you can do much more than what you could do before. For floating point, you can do something similar. Again, if you have only 16 bits, you are limited to this range, but you have a 32, which is called a single precision. You have much more, much wider range to deal with for your data type. If you have a double precision, you can do more. Then you can quadruple precision, and that's 128. But I'm not sure it's supported here, but it's in some other languages it's supported. You call it quadruple precision. You can handle even more data type, because 10 to 308 is already a pretty big number. I don't think mostly people will be using, quadruple unless you're dealing with some critical phenomena or something very sensitive to the precision significant data points. But again, it's also supporting complex. Complex is just like two floating point numbers. You can put them together. It's just like a pair of floating point. That's what a complex is most about. You can also do the big thing with a floating point, but I don't have an example here, but that's the same idea. So this is one example I want you all to try out. If you are doing any computational science or computational engineering, you should be careful about this kind of problem I'm showing here. Your professor wrote, in your numerical, probably computational science courses will tell you this is called a truncation error. You need to be careful, and you need to find some way to deal with this kind of problem. Whenever you have writing your code, don't put very small numbers in the denominator, and whenever you have a variable that could be very small, you should always put some padding. Say this number plus 0.000001. With that padding, you know for sure this when you take the inverse of this problem, this number, you're not shooting up to infinity or some huge number. You always have a control of how big that number could be. And that's some dirty tricks you need to put in your code when you're doing any computational stuff. So sometimes you'll learn that in a harder way. But that's some numerical tricks you need to deal with. But this one example, so for A here, if I do this 4 divided by 3, that's 1 plus 1/3, right? You subtract that by 1, you're supposed to get in 1/3. Then you multiply 1/3 by 3, you'll get 1. 1 minus 1 is to get 0. But of course, you won't get 0 if you are using floating point operation, because we are always have a limited number of bits to hold all the significant digits. We always have some error, numerical error. That's called a truncation error. And this truncation error will be very, very troublesome when you're doing numerical stuff. If your numerical scheme is unstable, this small error could be accumulated exponentially and quickly kill your application. So that's something we are doing in computational science, solving equations you'll know. But this is just one example. It's very extreme example for you to see what's happening here. So basically, that's what Juliet tell you. If you do this calculation, and you'll get all the numbers printed out, but at the end you'll see there is something goes wrong. It's not wrong. It's just cut off. It's just because we have a limited storage, we can only hold your data to that precision, and that's it. So 10 to negative 16. That's a maximum. No, that's a minimum. That's a maximum precision you can get for double precision. If you want to get to some value smaller than this, you need to go in probably using quadruple precision or even higher precision for them. Now, to handle this floating point types, big float is one way to go. And if you do this, if you don't change anything, don't change any setting, directly use a big, say big 4 by casting this 4 into a big integer, and this whole thing will be casted into big float, and then your error will be 10 to minus 77. That's much higher. That's much higher precision, accuracy compared to the previous one. But now you can do even better. You can change the precision to a, I'm not sure if it's arbitrary, but there must be some limit there, to a number, much higher number. After you change this precision, default precision, the big float precision and big integer precision will be changed, and you can get even accurate results. Mainly because the truncation error will be much less, and Julia is trying to keep as long as possible. I mean, keep as many digits after the decimal points as possible too, so that you can get a more accurate result.
That's precision for big. Right?
For big, yes, only for big. But always, as you can imagine, you pay a price. When you're doing engineering, nothing is free. So you pay the price for the computing time, pay the price for the storage, for the memory usage, etc. So, but sometimes people need this, need high precision, and you just need to know that you need to pay the price pay a price for that. It's a performance cost. Okay, for complex and rational numbers, you can do something similar, but I just leave it here. For rational numbers, it's kind of interesting. You cannot, when you put a double backslash there, Julia will not do this calculation directly to convert that into a floating point, data point, floating point, a double precision or single precision floating point, real number. It will just keep this fraction as a fraction. And this could be used as a rational numbers, and you can give you accurate results. For example, like 9 divided by 27 is 1/3, right? If you times this by 3, if you are doing this using the floating point, using the real numbers, you will get some errors, and there will be some truncation errors. If you are keep using the rational number data type, this will give you exactly 1. If you multiply 9 divided by 27 by 3, you will get exactly 1, because that's a special data type that Julia is doing something like a symbolic manipulation internally to take care of them. Otherwise, you'll get some truncation error anyway. So there are some mathematical functions. These are built-in mathematical functions almost everywhere. If you are using math libraries in C and math libraries in Fortran and some other, these are standard mathematical functions. Some of them are not there, but most of them you can find similar functions in different languages. We call this built-in functions. Now, of course, you can easily expand this with external libraries. You can implement your own functions, do anything you want, any function, any mathematical function you want. But here, these are built-in with the Julian. You download the Julian. These are something you can use directly without using external packages. So the built-in mathematical function in Julian are implemented in C, just for the sake of performance. It's pretty fast. Okay, we talk about numerical data types, big, which is kind of special, and we talk about some built-in functions manipulated with the different numerical values. And then next we'll talk about chars and strings. So chars and strings are very important for you to deal with any text information. When you're doing natural language processing, you're dealing with strings. When you're dealing with building a website, accepting people's input, you're dealing with strings. When you process anything related with the documents, you're dealing with strings. So the basic building blocks for strings are chars. Here we are mostly, when you talk about chars, you're talking about, most people refer to ASCII symbols, but with Julian, we are talking about Unicode, which has a much bigger table to play with. So you can treat these chars as integers because they are corresponding to, if you are referring to the ASCII symbol A, I'm not sure what the value of A in ASCII symbol is, 36, 37, or 46, 47. I forgot exactly what number that is, but you can do manipulations. You can do the multiplication or other various things with symbols because they are always converted back to the ASCII values, and then you can do the multiplication based on that. So, that's the chars and the strings. So to handle strings, you can treat strings as an array of chars. For example, if you define a string here as a hello world, the string 1 will give you the first. Wait a second. Why not string 0? Is this Julia? I'm sorry, Julia is 1 best. So, I believe MATLAB is 1 best. That's why I think that when they first designed this, they are following MATLAB a lot. So they are following MATLAB traditions and all the standards. MATLAB is 1 best. Python is 0 best. C is 0 best. Fortran is 1 best. Different communities have different standards, but sometimes it's easy to get confused. So and is a special symbol. You can use a string and, which will be more or less like -1 in Python. It will give you print out the last symbol in your sentence. You don't need to know how long this string is to refer to the last one. You just need to know end. That's all you need to know. It's referred to the last one. It's just -1 in Python. It's the same thing. You can get a chunk of it, like the last one here, 2 to 8. You can get from the second one to the number 8. So that's how you handle strings. The same way you handle strings in C and C++, right? C++ you can use a string, but in C you use arrays to handle strings in a almost identical way, like what we are doing here with Julia. And also you can do a bit more. These are some fancy things. I don't usually use this in my code. First, even though it looks good, right? It doesn't really help you. Sometimes it's confusing, and I prefer to use, stupid and simple. People call it keys, right? Keep it stupid and simple. That's my style. It's kind of like, it's cool to write down things like that to show off, but really, when you're writing engineering and scientific applications, you don't want to use all these fancy notations and ways of doing stuff. But anyway, I'm just showing here. It's here. It's available. If you want to use it, there are many ways you can put you can handle strings in a completely dramatic way. But for me, I prefer to define a variable and then I calculate it. I print it out separately. But that's different style. Some people like this. And also triple quoted strings. It's good if you have multiple lines and you don't need to worry about runtime. Just use a triple strings, which automatically ramps everything up without you to worry about escapes or for some special symbols. Triple quoted strings will give you everything verbally inside these triple quoted strings. So these are some more functions for you to deal with. Strings could be getting really complicated. We are talking about regular expressions. I got lost when I was doing this. For simple ones, it's easy to remember. When you start building up long regular strings to match certain expressions, it's getting kind of tricky. So that definitely, just like many others, you need some practice. You need to use it, many times until you know how to deal with this. But I'm not expert on regular expressions myself, but I know it's really, really powerful. And I started learning this when I was using Perl back then, many years ago. But I use that also when I do the VI, using VI on Linux for editing. Regular strings are very convenient for you to search do some query, do some quick search inside your editor. These are some functions to deal with strings. And again, as long as you understand a string is nothing more than an array of chars. And all the functions here that make sense here, like occur in, right? let's sort of try to find where this LIA happens, could be found in string. That's the first appearance will be, this will print the index of that LIA first appeared in the string. And also repeat is just more or less a play with the indices of the string and where it happens, etc. Again, this help function, this building online help function is very, very helpful. You can use a question mark and any function, and it will give you some detailed information about this for each function. If you directly press a question mark, it will give you the help repo, and then you can type in function yourself. So let's stop here and take a short break for 2-3 minutes, and then we'll get back to this part 4. Sure. Portal.
Can I run programs that are on my computer and my laptop using that, or do I always have to transfer it to the scratch folder and then run it?
Yeah, you needed to transfer because your code needed to be executable depending on what you're running. Say for example, the Python script, right? You can either open up editor on the screen and you can directly use a VI if you're not familiar with VI. If you are not, you can use there are many other options. You can copy and paste the code directly to the screen and you can do whatever you want. You can also use a Jupyter notebook. You can run the Jupyter notebook. There is a YouTube video clip show you how to run a Jupyter notebook on the computing node.
I see.
Then you can just use it more or less like your local Jupyter notebook server. And another way, which is something I want to show you all here, is to, if you have this, do you see this file? It's called a file. No, I'll show you where it is. Let me go back and so there is a file here. You can click home directory of Scratch. Let's say Scratch, because we'll be using Scratch anyway. Click Scratch. This will open up this file browser for you. What you can do, you can just click the file, edit it with your favorite editor on your Windows system. You can save it, it'll save to the, so it should be, or you can upload it, not save it, I'm sorry. You can save it to, sometimes you can edit, for some files you can edit. Let me see if I can edit some files. Like here, so for example, this one, I can edit. Now I'm directly editing remotely. I'm not downloading it, editing locally. If you edit locally, you need to upload it, and then you can continue using the file. Does it make sense?
Yeah.
So make sure you know, sometimes it's kind of confusing. The file sometimes is on your end, sometimes on their end, but as long as it's in the environment that under controlled by the port itself, then that's something you can directly modify. Otherwise, whenever you're editing something with some client which is not linked to or synchronized with our server, that means you need to upload it after you finish editing. Mobile Xterm can do something like this. You can directly edit, and it will automatically save it. I like Mobile Xterm myself. Mobile Xterm. It's very, very powerful for Windows users, and you can use this to do many, many more than just. You can run X Windows remotely and doing other fancy stuff. But again, for most users, I think the web-based interfaces should be sufficient to get started. But we're getting more and more, into this Linux user environment and want to use more about features and, the terminal can provide. Mobile Xterm is a choice for Windows users.
So if I already have like a Python code on my laptop and I want to run it using the web terminal, I have to first install Python in my.
No, Python. You remember how we run Julia? We load the module, right?
Yeah, the module.
Yeah, you can load a module in Python and upload your code there. Then you need to create a virtual environment for yourself on our machine, and then you activate your virtual environment and then run your code. But you need to upload your code to the server first.
Do I also need to install all of the libraries that are in my code?
Yeah, you need to install you need to do the pip install in your virtual environment. let me see, I should have one file I created a long while ago and updated recently. It's in my Google Drive. I can share with everyone. Here, let me share with everyone. You can, this probably be helpful. It's not, I'm just using this for my old development a while back, but again, this needs to be updated, regularly, because sometimes, we get a new version of CUDA, or something's installed. We needed to, if we want to use some latest version of this, some packages, you probably want to do that regularly. If you have access to it, paste it to Zoom, so it'll be easy. Kind of awkward. Everyone, you guys here in person, but you have to log on Zoom to share all the things. But make it convenient to share files, share links. Okay, so this is not directly, what I'm sharing here has nothing to do with Julia. It's just a Python. But this, I'm offering this service, buy one for free, right? Buy one, get one for free. If you come here to learn Julia, you can learn something about Python. Okay, let's get back, because we still have a lot of materials to cover, and I definitely want you all to get your hands dirty on some of these things. So functions. Well, I mean, when you define function, there is a keyword here called a function, func, and etc. And then you can define, you can use Unicode symbol to define a function name. The same, like you can name any variables and use a Unicode. You can use a Unicode as a function, but it's not working on a web-based interface, but it's just let you know it's something working. Let's see what else. Again, a function is like a ramper for a bunch of statements with a given input and expected output. If you are clear about this, if you write a bunch of statements that can take certain input and you want to produce some certain output, it's usually a good idea for you to write a function. One thing is that a function is a callable, and if you get this one thing done, others don't need to copy and paste your code. Just need to call your function. As long as they have access to your code, you just need to write this once. So the whole point of doing program is just we want to write something once and use it many times. The function is one way for us to do that. And also function is a fundamental building units for all the programming languages. And when you're building up, a big building with different blocks, you first build up relatively bigger blocks, and you then use all the big blocks to building your house. And all the statements, those are fundamental smaller blocks, but the functions are more or less the bigger blocks you use to build up your house. This function could be big, could be very big. You can have one function just to do the whole thing. For example, in C, you are just calling the main function. Main function contains everything. The good way of writing a program is just have a big function there, do everything you want, and then start refactoring your code by putting different part of your code in different modules, different functions, and then write them separately. You can organize your code that way. So again, learn to write and use function. It's very basic skill to do the programming. But usually when you get started with the programming, doing programming stuff, you just want to write statements because that's straightforward, that's easy. But gradually you will learn that functions are actually much more important than just writing statements. So you can have optional. You can have optional arguments similar to Python. In Python, you can have a positional statement, positional arguments. That means those arguments will have to be in a certain place, in a certain order. And then you have some optional arguments, and you have some default value already set, like Z here. I define my function point to take 3 input, but if you give me only 2 input, it's fine. I'll take your 2 input as X and Y based on the position you have. The first one will be sent to X, and second one sent to Y. That's called a positional argument. The last one is optional argument, and it has a default value.
Why does it output 3 here? What we defined it with the 0.
Why? I'm sorry, what's that?
Why does the output? Oh, sorry. That's
not output. I'm just trying to just run it. I want you all to try this out, on your terminal and try to see what you will get. If you just call the function point with 2 arguments, 1 and 2, the print line will print out 1, 2, 0. But you call your function with 3 arguments, 1, 2, 3. The last ones the last argument will be set to the value of z, because the default value of z won't be used. It will be using whatever you give here, which is a 3. So by doing that, you can see this is very, very powerful. You are just writing one function, and this can take multiple input. Just imagine you cannot just take one optional argument. You can have multiple optional arguments. You have some other keywords arguments. Just in the same way, Python is supporting this optional arguments. In C or Java, you probably need to do so-called overloading, right? Function overloading. You define new functions, but here in Python and Julia, it's just a different perspective of doing things. So do you have any questions so far? Now we are getting a little bit deeper on the function side. So it's not just a single function, simple function. You are trying to write a single function with multiple forms that you can take different input, and your output will be trained corresponding. Even though you're just writing a one single function, and this function will be very powerful. Okay, so next one will be the keywords and position arguments. As I mentioned, A and B, these are position argument. And keywords argument like a C equals to D equals to, these are two, position arguments. You use semicolon to separate them, and for unlabeled arguments. So the last one, D equals to 2, actually that's the separate. These are labeled arguments, the two labeled arguments. I think the semicolon here is separated the first part, the second part. The first part, C equals 1, this is an optional argument. The last one is a keyword arguments. So there are differences, like one here, Z equals 0, this is not a keyword argument. This one is an optional argument. But here, D equals 2, this is a keyword argument. And C equals 1, this is like optional arguments. So when you write down, when you try to call a set of value for D, you have to say D equal to something too. You have to put it there. But where it is doesn't really matter. But you have to put a D equals to 2 so that the function knows that you want to set D equals to 2 instead of some other things. By using this keyword argument, this particular argument could be in anywhere. It doesn't really matter where it is. So this will be taken out. For example, if you look at the function equals the second function in the last line of this slide. This second function here, D equal to 4, is at the very first argument position. But it doesn't matter because whenever you have this keyword argument, this will be taken out. This will not be considered for your position. It will be first pre-processed, and then it will try to set a value of D to 4, then it will start counting the position. So 1 is still pointing to A here in our function definition. B will be set to B, 2 will be set to B here. And the last one, 3, will be set to C, because C here it's optional argument. If you don't set it, the default value 1 will be used. If you set it, the default value will be overwritten, and 3 will be used for where the C is. But now the key thing here is a semicolon. This semicolon separate these keyword arguments and all the arguments. So these are the tricks, you don't worry about it for the first time, but these are the things you want to learn to use to make your functions more flexible. And we use this a lot in Python. If you use Python, you know a lot of arguments. You don't need to specify words. You need to specify, keywords. And it's just like keywords and position argument as I mentioned here. It's the same idea in Python. Okay. So now we go to another more interesting function called anonymous functions. So in many cases, you want to define a name for your function. You want to call my function and. You will do A and B and A, B. Then you want to do the addition of A and B. You want to do the sum of an array. You give a name for it. But in some cases, you don't need a name, or you don't want to give a name, or it's just like too much burden for you to write actual function name for it. So how to deal with those kind of cases? So in Julian and Python has a nominal function, which is a anonymous function, corresponding to anonymous function here in Julian. So you don't need a name. The anonymous means nameless, right? It doesn't have a name for that. So you use this whole thing, anonymous function, more or less like a variable without not variable, like nameless variable, like a storage without a name. And it uses just the same way you use a lambda function in Python. You define it somewhere, and then you use it internally without giving a name for it. Mostly, this anonymous function is used for mapping. If you have this function defined, and you want to map certain input to the input of the function without naming the function, you can just directly do the mapping and just using this dash greater symbol to help you to identify that you are trying to do the mapping from x to 2x minus 1. This mapping actually gives you the function, but you don't need to name it. So again, this is something more advanced abstract function and anonymous functions. These are the advanced topics. For new, I know some of you are probably new to programming. Don't worry about this one. You can learn how to use this anyway in the future. But in many cases, you don't have to use anonymous function. Sometimes it probably be easier just define a function previously and use that. But in many cases, you can find a lot of anonymous functions in libraries and in other places. But as a programmer, you want your code as explicit as possible, just for future reference and for readability kind of consideration. Yes. Do you have any questions?
How do you call like if I just write x arrow 2x minus 1? How do I call it?
Well, it's just you can use the output from previous value. I think it's there's a special symbol to represent the previous statement output. Yeah. The output will be used as the function output. I forgot I know the MATLAB has a NS. I forgot I know MATLAB has this special symbol that you can directly refer to the previous output of the previous line. I think Julia has similar things. I did look into that one. But yeah, I'll do a quick search during the break. You can use that one and then use whichever value as the input as your anonymous function to call them.
Are anonymous functions usually used with this in this way where we don't have any name for the function?
But you don't need a name. For example, you do the mapping, you don't have to define a name for the function, right? You just say, I want this to be mapped to this, and then this is my input. Just do the mapping for me. I don't have to define extra function to do that.
Yeah. I mean, I've seen the use of lambda functions in Python, where we usually do the assignment and the function, define the function in the same step, like you've done.
That's still name. Is it name? You could use return to assign it.
No, the nominal function itself is not a name. I think, for example, when you
like the lambda style for functions still has a name.
No, I don't think you give a name for it. For example, I do that a lot with, say, Panda pandas apply and mapping, right? When you apply, when you want to apply certain functions to that, that's when you can use a lambda function directly in your statement, or you can define a function. Then you can do apply panda, PD, data frame dot apply this function. That's one way. Another one is you can use a lambda function in it. You don't need to define a particular name for that function. It's just lambda function. So it's the same way like the anonymous function. It's just use it the same way.
But like for lambda function, you still you define the function object as a lambda function, and so then you can call that function name. It's still named. It's not anonymous.
It's probably in the same way like here. Let me try this way.
Like calling map.
Yeah, let's try this one. So let's X. It's not so I can define a generic function with one. So that's what it returns. So what you are saying is like you can define say z equals to, right?
Yeah.
So you can define. So even without name, this function itself is still a function, but you can it's your choice to see if you really want to assign this anonymous function to a certain object or certain variable. Does it make sense?
When we manipulate arrays and we use that lambda function to take in each iterator in an array and then apply some mapping to it and then log. Without this, let's say I have to add 1 to each element of an array, and let's say that I don't have a data structure that supports that.
Yeah.
So I can iteratively using a lambda function call each element of that array, and then use a lambda function to add 1 and then return that. So
I think it's mostly like a notation kind of thing. There might be some other ways to use it more abstract way. But my understanding is that if you want to do something quick without predefine some functions, you can directly write the whole mapping and application apply function together with a function you directly write into the statement without predefine a function beforehand to do that. But again, as I'm just showing here, if you don't define like a variable like a z here to hold this, the system will store this into this somewhere in the memory, but it doesn't just have a name tag attached to it. It just still keep it, but you don't have a name tag attached to it. But now if you give it to z will be more or less like a label, like a key pointing to this value. This value holds this anonymous function. And this anonymous function can still work if you call z this way. But I'm just trying to figure out what's the best way to call the, I'm not sure if I never tried it, if it's work this way.
Yeah, you can assign it to things and it works like that.
it's working on the first one.
It seems to be the second example of the map example.
Okay.
Transform your inputs.
The second example
With
here.
the subclass.
Yeah.
Yeah.
Right. So you pass the function as a parameter.
Yes. Yeah, but I think this is different from, do we really need a lamp tag for this? So actually, if you really want to define, you can even define z equals this whole thing, just map z, and then it will also work. It's just like, why do you have to write it this way? Or can you just define z equals to x, y, z map to x plus y, z, and then you can just call, I'm sorry, another function, say f. So, but anyway, so I usually, write down these functions explicitly just for my own sake. just in case if I only have very simple mapping like this, I'll do use an alignment function in Python to do that. But in most cases, I just write down the function explicitly so I can keep track of all the functions in a separate library I'm keeping track of. Okay, that's about the alignment function, and there are many other examples online. You can try things out. But there's a very, very special function here. It's called a dotted function. It's building. It's like a building for free for you. You can define a function say AB equals A times B, right? Nothing special. You can define a function like that. And Julia will automatically generate this dotted function for you. What it does is that if you after define this function AB, you can directly use a func dot as something with the input. What this does, it will take your input and do the element-wise operation based on what you define with a func. It's pretty cool. So it helps you to not only do this, but also do things in parallel. So it's pretty, I believe it's doing this element-wise in parallel. So it's pretty fast. And it can not just arrays, but also matrix, multi-dimensional matrix. And then you have the matching dimension. Even if you don't have a matching dimension, it follows the standard element-wise operation for different dimensions, like the example here. The first input is 1, 2, which is an array. The second one is just scalar. The element-wise the operation with the scalar and array is just the scalar times each element of the array. So that's 3 times 1, the first element, the 3 times 2 for the second element. That's when you don't have a matching dimension. If you have if the second one is 3 and 4, what you will get is just 1 times 3 and for the first element and 2 times 4 for the second element. So you can do this, with like less seed function like this. The default function, one of the building function like sine and cosine, those also have a default dot function implemented automatically. That's more or less like a so-called syntax sugar, right? So you don't need to change anything inside this function. Just one simple syntax addition will give you the extra power for doing element-wise operation. Just in case you don't know how powerful this is, for those of you probably familiar with the Fortran 90, right? For one of the big features that people like Fortran 90 compared to Fortran 77 is that Fortran 90 can deal with arrays in the same way like dotted function here does. So you can define a function, and the Fortran 90 can directly take arrays and do the element-wise operation for you. And that's a pretty big thing in the Fortran community to do this high-level mathematical operation. So functions could be nested. You have a functions of functions, because function itself is just object. You can use that as an input. And another function can take your function as an input and output something. So you can define a function of function, and you can define a function of function of function again and again. It could be elastic. So yeah, I'll probably stop here. You can try things out, and this gives you a bit more freedom to create functions like functionals, and you can create a group of functions based on the input, and this gives you probably more freedom about your particular actions. When we talk about dealing with variables, every time you can define an array, and for each element of the array, you can do something, and then you can iterate through the array and apply a certain action to all the elements. Now think about this: you can define a functional function, then it can, based on your input, the form of the function will be changed, right? And the form of function, after the form function is changed, you can have more freedom about this particular function applied on certain data types. And that's give you another layer of freedom to do your operations, which is very powerful and kind of dangerous in a sense. It's probably easy to make mistakes again. Some more power you have with the program language, just more ways to make mistakes. But that's what the beauty of Julia is. That's most people like Julia about. Okay, don't stop. Let's go next to the data structures, tuples, arrays. These are very, very, very similar to Python. So I'll go quickly because I know most of you, needed to have some programming background, right? At least learn some bit of Python, and learning this will be helpful for learning Python as well. So tuples are kind of like arrays and like list, and but tuples are immutable. That's very important. Being immutable, that means you can have very, very high level optimization done about how you access this thing and how you to copy and play with this. If things are mutable, that means you need to keep some extra functionalities to maintain the mutability. But if it's immutable, then you can do whatever you want. The remaining optimizations could be done on immutable arrays. And the tuples are just designed for this. If you are dealing with a pretty big arrays, the first thing to do is probably if the whole thing is immutable, you probably get much faster performance for doing all the operations. So again, tuples are just immutable arrays, and it's faster, and in most cases, and you can just use it just for reading purposes. Consider just a read-only array. That's what tuples are. So arrays are mutable. It's just like list in Python, and you can have built-in functions to generate a list like Python as well. For example, the D. If you look at A, B, C, D, D here, it's you can use that to automatically generate the list, the members of the list of the array. And also be careful about the column vector and the row vector. If you don't have a comma separating them, it will be a row vector. It will be one row, second row, third row to define this vector B. B will be like a vector, right? Row vector. If you have a comma, it will be separated into separate columns. It will be 1, 2, 3. It will be column vector. And again, you can define. It's not a vector anymore. It's a matrix. 2 times. It means that you have a 2 times a 3 vector. You have a 3 vector, but it's a 2 rows of a 3 vector. There are some built-in functions like zeros, random number generations, and ones. These are also standard functions in Python as well. And then you can reshape your file to different shape, but make sure you match the dimension here. So 5 times 3 5 times 6 should be matching 10 times 3. Otherwise, you'll have mismatching error. But what it does is just following the order. If you have 5 columns, 5 rows, 6 columns for the generated random numbers, what it does is just take the first row, and then get a second row. Okay, then after they reach out 10, it make everything into 1 row. I'm sorry, this is 10 rows. I'm sorry, 10 rows of 3. You start with the first 3, put it in the first row, and second and 3, put it in the second row, etc. Until you reach, or finish all the 10 rows for your variable. You can also do the horizontal concatenation and vertical concatenation. If you put a column, semicolon there, B and B will be vertically stacked together. And okay. So the array and the matrix operations, as you can see here, the dot operation will be used here. After you define this B as a matrix, 1, 2, 3, 4, 5, 7, 7, 9, 8. There is a reason why I put a 4, 5, 7 or 4, 5, 6, because we are doing inverse. If it's linearly dependent, you'll get singular values. You'll get infinity. That's why I changed the 4, 5, 6 into 4, 5, 7. And then you can use the dot operations. And the dot plus will be do the element-wise plus. So 10 will be added to every element. And you can do something about that. And again, you can apply the dot operation to the science function and doing all that. You can do the transpose and other things. These are matrix operations. We are dealing with a lot of numerical values. These matrix operations will be very handy for you to play with those. Otherwise, you needed to do all this, all the things yourself. But these are very handy for you to play with this, not just one or two. It's a big, a big array of numbers, and also play with different matrix layout. Also, now it goes to sets. Sets are like a list, but they should be unique. If you have a repeating element in your array, one quick way, that's what I usually do. If you have a lot of repeating elements in your list, you want to make sure every element is unique. You just do a sets, parentheses, your list, and then all the repeating elements will be removed. You get a unique set of all elements. That's what I usually use sets for. I don't use sets a lot myself, but that's helpful for you to remove all the redundant data set. It's the same idea here for sets, and similar idea, probably same, just like Python sets. A dictionary is almost identical, but now using dick, dict, to define a dictionary. And also the symbol a little bit different. You use equal and greater than symbol instead of a colon, right? Used in Python. And other than that, I mean, everything else is almost identical. You can use the square parentheses with the name of the key to refer to the value, etc. So now you can see, Juliet, people call it Python on steroids. It's just basically it's Python with a different syntax, but there is a bit more performance when you are doing numerical stuff. Now, this is part 6. I think we're almost there. When you start writing programs, you need to think about some structures. And this is a structured programming, flowchart. You start with your program. You have some conditional statement. If certain condition is satisfied, you do something. Otherwise, you do something else. And after it's done, just end and exit. That's the best workflow. Of course, you have loops inside. You have many nested, nested if statement, and you have you have nested loops, etc. By putting all those things together, you are supposed to be able to use this combination of loops and conditional statement to construct most of the business logics that you might be encountering. And I'm not sure if it's mathematically proved, but I think even if it's not, it's still reasonable to say that with this combination, you can probably express any kind of possible logical conditions, as long as you are willing to just explore the possible branches that in your business logic, and I believe when I was taking this Fortran course many years ago, that's a very good example for structured programming. So you're writing your code in blocks like this with start and end, and then you have everything in between. You wrap everything up as a module. And inside this module, with this combination of conditional and the statement and the loops, you can implement all logics in most of the calculations. If not all, but I think most of the calculations could be expressed in this combination of business logics. For controlling blocks, these are a couple of controlling blocks. You have switching, Boolean switching. Ternary is kind of like simplified if-else statement. So we can just treat them together. Boolean switching is also kind of like an if-else statement. So if-else, else, if, else, and statement is pretty generic. Could be used to replace others. For and is the iteration loop. While and is also iteration loop. And the catch error, this is like a debugging for debugging, for catching errors, exception handling, etc. So basically, the basic logical building blocks are just the if-else, called the conditional statement, and the looping statement. Those are the building blocks. If you know how to deal with those and play with those nicely, you can build up any program with it. So ternary or Boolean expressions and Boolean expressions, those are the pretty regularly used for, as a part of your statement, conditional statement. For those of you who are familiar with C, the second example here, x greater than 0, question mark, sine x, column, cosine x. So what it does, it will first try to tell if your x is greater than 0 or not. If it's greater than 0, the first statement in front of the after the question mark and in front of the after the question mark and before the column will be executed, will be evaluated. If x is less or equal to 0, the cosine x, which is after the column, will be evaluated. So that's ternary because you have 3 parts. Ternary, I believe it's probably means 3. I remember it's Latin or Spanish. Ternary. It's probably people telling me it's like 3, but I never looked up. But since you have 3 parts, 1 part for conditional statement, another 2 for different branches. You have 2 branches and 1 conditional statement. So that's ternary. People like it in the reason that it's easy to write your if-else statement in just 1 sentence, and it's make your code much cleaner. And also because in many cases you just need to worry about 2 conditions, and this is sufficient for you to to deal with some simple cases. Also, you can also use Boolean conditional statement like and or to put things together. I think that's it. For conditional statement, if something happens, if something is true, do something. Else, if something is true, do something, and else. So these are like plain English, right? If you are an English speaker, I don't think this should be anything to worry about. It's just like a special syntax, like else if. You need to put else and if together. And else and you need an and statement for the whole thing. So there's no switch and cases. If you're familiar with the C, there is a switch. Switch A equals 0, or switch A equal to 1, switch, whatever. Switch A, you can depending on the position of the different cases, you have different branches. But anyway, that's a conditional statement. I think nothing particular about it. And then next is about a loop controlling statement, for loop. If you know that you have this many iterations to go, and you know where you want to start, where you want to end, it's always a good idea to use for loop because you have a very good control about where you want to start, where you will stop. Like here, the first one, I want to iterate from from 0 to 10 with a step 1, I believe, is actually. Yeah, I'm going from what's it's a different notation than C, right? C is starting with a start and the step, and 14 here, junior here is a start, step, and end. So here 1 is a step. So let's just do a quick run here. Just let's copy this one. I hope my session is still running. Okay, good. So what it does is whenever x could be divided by 3, wait a second, I can continue. So it'll skip all the multipliers of multiples over 3. What I'm doing now is I just skip all the multiples of 2. So whenever I have a 2 or a multiple of 2, I'll continue. I'll skip my current statement. Otherwise, I'll print out the line. So 0 is a starting point, the starting number, and 10 will be the ending iteration. And 1 here is a step. Every time it will increase by 1. That's for the given number of iterations. It's an integer number. You have 10 iterations. But if someone give you a string, a string is nothing more than an array of chars. So here, the second example here is just like shell script. For I, I'm not sure it's L. For L in Julian, this Julian is just whole string. It's just like in an array of JULIA, the list of these characters. For every character in this Julian string, you print it out. And then you link them together with this symbol. And you can try this out as well. So this is the fourth step. Nothing special about this, just for a particular iterator going from the starting point to the end point with a certain step, and then you do whatever in between. And that's how you do the iteration. There are other uses for for loop. For loop could be used for comprehension. It's not indent. Yeah, Juni is not indent sensitive. It's a very free format. You can do, it doesn't require the indentation. I believe one of the developers of Julian, they're boasting about the free format compared to Python, mainly because a lot of developers for Julian, they hated the indentation very much, and then that's why that when they design Julian, that they try not to repeat what Python people are doing. So let's see what else. For the array comprehension, yeah, I mean that's why sometimes you can use a parenthesis, even though you don't need it in many cases. But a lot of C programmers prefer to put parentheses, curved parentheses around their statement, so that they know these are different blocks. And when the compiler code, it just ignores the parentheses because those are useless extra symbols. But it's helpful for programmers and other developers to see what's in different blocks. And you can use a for loop inside, internally to generate expressions, and you can use this in a very freestyle format. So for loop, array comprehension is also a common technique in Python to generate arrays and lists, for the initializing your arrays. You can do enumeration for arrays as well. You can also do, nested loop as well. You have a for loop inside a for loop. It's just if you have multiple dimension array you want to iterate, that's usually you use nested loops. While loop is kind of different. While loop usually have a condition to get started, and when you're internally, you need to modify the value of that depending on the condition. Otherwise, you'll get into an endless loop. So every time you need to modify this value, and then whenever this whatever inside this while loop finishes, going back to the next loop, the condition will be compared first. If the condition satisfies, it will go into the loop and then iterate one more time. If the condition is not satisfied, it will quit. So while loop is kind of different from for loop is, and for loop is always do the comparison first. Whatever you have n, it will compare n against 100 to see if it's less than or equal to 100. But if you have a for loop will do something first, then it will evaluate if your n is beyond the range set for the iteration. So that's some difference. But again, this for loop and the while loops, they can both easily switch in many cases. But in some cases, if you don't have, if you are trying to iterate, doing some iterative solvers or doing some approximation, and you don't know how many steps you have. All you know is that I want this tolerance to be less than 10 to minus 6. And it will be easier to write this kind of statement with a while. But of course, you can do the same thing with for loop, but then you will probably need a very big number just in case you didn't get to the tolerance. And then you put a statement inside your for loop inside. Whenever this tolerance is less than 10 to minus 6, you'll quit your existing loop. So in that case, while loop is probably a better choice for those kind of loops. But again, if you know exactly how many loops you want to do, I'll be highly recommending for loop for that kind of stuff, for that kind of looping conditions. Okay, that's while and for loops. And exception handling blocks, these are very useful for you to catch any errors. Could be system errors, could be your bugs. And I use this really a lot in Python. And sometimes I can even take advantage of this, because in some cases, there are some special, exceptions you want to use as a conditional statement. I know it's not a good practice, but I know people do that. I'm using that. So in some cases, if this value is not initialized, you want to use it first to do something. And whenever there is an exception appears, and then you will initialize it. Otherwise, you'll just go ahead with a value, whatever value is stored inside of the variable. That's also how you can use a try catch to just do something about it. So lastly, it's about plotting. Unfortunately, I don't think any of this plotting works on our portal terminal, but it's just so simple and so beautiful. If I'm using a Windows terminal or Mac or even Linux terminal, you can remotely log in our Grass login nodes and run your Julia, and you can plot ASCII plots like this. And I was really impressed by this plot when I started with Julia repo on my Linux terminal. This is ASCII plot. No, not ASCII, it's really Unicode. I'm sorry. These are using Unicode. Probably ASCII. I need to double check. Unicode, right? So you can draw not just simple lines, like you can draw complicated plots with called a Unicode plots function, which is one of the functions inside of the plots module. That's really useful if you don't have access to a graphical user interface, or you don't have X forwarded to you. But if you are running things on your Jupyter notebook, or you have a separate Julia IDE, you can just directly using the plots, they're called a Plotly interface, which is just a standard Plotly. We will generate JavaScript-based HTML plus JavaScript to plot interactive plots like this. It's very, very powerful. And I use it a lot in my Python package, in my Python projects, and plot out interactive stuff. And that's Plotly backend. So the front end, it's the same. Everyone's using plots with the same interface, same API, but you can load your different backends. You can use a Plotly and backend, and you can use a Unicode plot and backend, but the front end will be the same. So this is useful if you have a Jupyter notebook running on your IDE, and also if you are Juno. I believe Juno also works well for this. And then lastly, this one is called a GR framework. This is another plotting library. It's working. It's not as interactive as a Plotly, but it doesn't require a web browser. It can generate as long as you have a terminal, it will automatically create this window for you. You can dump it, you can save it, you can do many other things about it. So this one is using GR framework, and you can click the link and it goes there to check it out. So these are three frameworks. I believe there might be some others popping up lately, but I haven't really checked. But these are three ones I used myself just for testing and other things. Most of the time I'm using this one actually a lot, because in many cases I directly log into our servers with my terminal, and I can just do a quick plot with Unicode plots. And at least I see the trend. That's what I usually want to check. If it's getting bigger or getting smaller, at least this one can help me to directly check it without me worrying about running any X Windows applications remotely, which is a bit more complicated in many cases. So, that's a very simple introduction, and just like Python, you need to learn much more than simple syntax and structures to write a good Python code and develop Python packages. You need to learn how to use Python classes. That's something we didn't cover here. For Julia, you need to learn how to write Julia classes, and almost all the Julia packages they're packaged up using Julia classes. They have their own internal functions and many other things. And we are not covering that part. And also, there is a very, very big community called the scientific machine learning community that Julia is behind it. And if you do a quick search, scientific machine learning, Julian, and you can see the whole Julian company, I think it's Julian Computing Company, is behind this initiative. Because scientific machine learning is getting bigger and bigger. People are trying to use the machine learning technology to solve equations, and they can do things in a very, very efficient way compared to the traditional solvers. So that's a very, very hot and interesting research area, and a lot of people here at NM are working on that. But Julia is one, and also our team here at NM, we are mostly focusing on Python-based modules. But in my first short course on scientific machine learning, actually, I was using the Julian package to introduce that. But again, currently I'm switching to Python for the development work. Oh, there's one thing I want to mention here. There is one MATLAB Python Julia cheat sheet, which is very, very cool. And if you are familiar with one of these three languages, you can easily learn other two quickly. So look at this, it's just so beautiful. If you are familiar with MATLAB, you can easily learn Python Julia, just, okay, that's what I need to do, I was teaching a short course. I believe that's Python for MATLAB users or MATLAB for Python users. I forgot which one, but I did a course to compare MATLAB and Python together during the whole course, short course. I believe I was trying to teach Python for MATLAB users. So what I try to convince people is that the Python NumPy, it's just easily replaceable, almost directly replaceable with all the MATLAB stuff. If you have MATLAB function written, as long as you're not calling some external third-party packages, you can easily convert them into Python NumPy, function, stuff like that. Of course, if you're using some MATLAB Symlink modules, there's no way that you can find an alternative in the Python community. But if you're just doing basic programming, it's very, very easy to convert that into Python. As you can see here, for almost every statement, you can write down in MATLAB, you can find a corresponding statement for Julia. This is a very good learning resource for many of you guys who are familiar with either Python or MATLAB to get started with Julia. So with that said, I think that's all for today, and I hope you all enjoy this short course and learn something about it. So for those of you who are new to programming, I think this could be one of the opportunities you can start learning programming. Programming is the language that you use to communicate with machines. Just like I learn English to communicate with you guys. If I stay in China, if I learn English, I wouldn't be able to talk with you even. But now I can talk with you, I communicate, and I can exchange ideas. In the future, a very near future, everyone needs to talk with a computer, either through some fancy interface or through programming. So we are engineers and scientists, right? We need to talk with a computer at a pretty high level. No, probably lower level, not high level. High level means probably natural language or probably gestures, right? That's what we are working on. We're trying to say things in natural language and ask machines to just listen to us, understand what we're doing, what we want, and that's a user interface part of the story. But for us, a programming language is a way to get into a different world, different universe. So now metaverse, right? That's programming will get you there. So. Okay, I think that's all for today. I'll be around for another 10, probably 15 minutes. If you have any questions, feel free to ask me, and I'll be answering questions through chat channel if you want.
Show an example of how to run a using
Yes, that's a good question. Let me see. I had some slides before. I'm not sure if I still have them. Let me double check my older slides. This is probably just write-ups for. So I believe just a couple of years ago, I don't think I keep some notes here. You needed to install after you get to a Jupyter notebook. You need to install iJulia, I believe. That's the package. iJulia, Jupyter, I think. Yeah, this package is something you have to install. After you install this iJulia, when you, you have iJulia?
So yeah, I can run Julia and Jupyter notebooks, but how do I use the HPRC to run my code if I have?
So you need to start the Jupyter notebook first. So we do have some YouTube video clips on our YouTube channel to get you started on Jupyter notebook, and then you needed to install this iJulia package, and probably needed to restart the kernel and try things. I believe we tried that a couple years ago. Probably when we first started teaching this, we were trying to use the Jupyter notebook for all our Julia courses. I'll dig out the details and get back to you. You can leave me email, I can get back to you. Yeah. Should I stop sharing or it's all right? Probably, I still have 8 people, probably half of them are from HPRC. So. Oh, okay. Yes. No, R is getting really popular now, but Julia is getting like this. There must be some reason, yeah. Yeah.
Yeah, I can do that as well. Yeah.
Yes, exactly.
You mentioned the Juno was the IDE.
Juno is IDE, but I don't think we have Juno on our server.
Well, I looked up the website for Juno.
Yes.
And there's a header saying that they already published the last update, and they'll just be developing the VS Code.
Okay. So VS Code will be the future.
VS Code has the extension.
Okay. Okay.
Works pretty well.
VS Code. Yeah. You know, a lot of people. The similar package as that's a good question. I used X-ray just a couple of days ago to just play with a netcdf file. Someone was asking me about X-ray. X-array. I never used X-array with Junior, but I used the X-array with Python just a couple of days ago. It has a Python interface. And so that's what I'll do. I'll just do a quick search installing. So they have, I think there is a Julian array, access array. No, that's probably different. Here we go. There might be, so I'm not sure if there is for X array. So actually, even for Python, which I would recommend you develop some code you can run and develop on your laptop with PyCharm or Jupyter Notebook, and then you can dump that into Python script, upload it, and run it on a machine. So with our system, it's not very friendly for developing interactively. So that's my impression. It's very good for doing a lot of computation in the backend. That's what all the job script and queuing systems are for, right? It's used for submitting jobs, running in the backend, get the results, you download it and analyze it, etc. So, sure, I just used an X-ray, yesterday, the day before yesterday. So feel free.
So can I ask? I can
Sure, go
just
ahead. You can talk.
maybe easier. So right now, I'm working with the netcdf files, and basically with the World
You can go
Ocean World Ocean Atlas dataset, and I'm trying to do some computation with the dataset that I load from the NC files, and it seems like the output data sets create a very high tags count in. I'm not sure. Can I share my screen? And
Sure. Let me stop sharing, and you can share. Let me stop sharing my screen, and go ahead and share your screen.
all right. I think I have no permission right now.
Oh, let's see if I have. Can I?
Just oh, everyone see my face now.
I'm a co-host. I'm not sure I can make you.
Maybe we have to ask Keith.
So, Kiss, are you able to allow the user to share the screen? I don't think I have the option here. Probably.
What's the user's name?
RRATTAN.
Okay.
Ronagrid Ratanasiam.
Yeah.
So my
Is that like a Thailand name? Something?
yes, I'm from Thailand.
Okay. Okay, now you can share. You're made a co-host. So.
All right, thank you. So I think I'm not sure this is too small or too big, but what I'm curious right now is that for an example, even though like for these data set, I load directly from the website, the
Yes.
NOAA website, and the size of the data sets is around 400 megabytes, and it's only like 12,000 tags. But after I like calculate and operate something, the output array have very high number of tags here, and I'm curious that make the, like for an example, if I wanted to do some values, it takes a long time. It's longer than it's supposed to be. So I'm not sure that how can I like minimize, or whether this is the cause of the slow performance, something like that. Like,
yeah, I understand. So
because the original data set, it's not very high number of tags, even though they are like larger files, we can output the values pretty fast comparing to the one that I just recalculated, the data set that I just recalculated.
Yeah, I think so the number of the task here as corresponding is something you added. I'm just trying to figure out why it's dramatically different. It's after you analyze it, you generate extra tasks.
I think so. So for an example, these are the original data set, the TS_month. And these original data set is coming from like 12 months. So right now we have 12 months of each grid, of each cube, which is the like temperature data for the ocean.
Sure.
And then I select one variables out of the data set, and then I calculate it. So there are some calculation between the temperature and salinity here using a function that I write earlier. And then that's the output. So I'm not sure the tags, it's mean that they count every calculations when I'm doing the calculations or something like that.
Yeah, is it possible that you modify the dimension somewhere, or since the dimension is unchanged, the shape is okay, it's the same, right? And
yes, the shape is the same.
Fine. The chunks, can you go back to check the original chunks for the previous line? It's What's the number of chunks?
So right now I'm doing
That's 82. Okay, 82,000 about. Okay, let's go back to the second one here. Okay, it's 82,000 about. So task here is just try to spread the, I think, the computation into different, depending on how the X-ray handle all the computations. Shouldn't be a problem. I think it's probably something else getting in here.
Yeah, so for an example, if I'm trying to do similar thing, like if I'm selecting the lat long depth.
Yeah.
Near,
Great. How about you send me an email? Do you have my email address? We can
yes.
find a time to talk about this. And I think others might need to leave anyway.
Okay, that will be great. I can talk to you
Sure.
later.
You should find my email online.
All right. Yeah.
Okay.
Thank you very much, Dr.
Sure. Thank you. Do you have any other questions about Julia today?
I use Python a lot, and because of the slow performance of some of the.
So you want to switch to Julia?
I'm not sure whether that's doable or not, but
okay.
Yeah, that's what my main concerns, and that's why I'm wanted to learn Julia, because
okay.
Yes.
Let's find a time to chat about it. I think the X-ray itself should be good enough. If it's not working, we'll see how we can help you about it.
All right. Yeah.
Okay. Thank you so much.
Thank you very much.
Bye-bye.
Have a good one.
That's all.